3.2 is functions. We need to recall that when we talk about functions, we're talking about f of x kind of deal. So this would look like, say this, 3x plus 3. Okay, so this is just the function of x is 3x plus 3. That's how you would read it, the function of x. And if I said, what is f of 3, that literally just means I'm letting 3 take the place of x. So it would be 3 times 3 plus 3, that's a lot of 3's, would be 12. Okay, so it's literally just asking you to plug that in if you ever see a problem like that. Okay, but remember that f of x is the same as basically y. That's the way we've traditionally seen it. It's y equals 3x plus 3. So these two things are the same. F of x is just an output. That's all it is. It's the output. Is the thing that determines the range. Okay? So that's all it's talking about when we see things that are written in function notation. So you would literally just write whatever variable they're asking you to use of whatever variables in the problem. So this is function of my input. So x would be my input here. Okay? So if it was, we'll get into several examples. So we'll just go farther into it when we get into the examples. Okay? So we need to be able to identify outputs, inputs, dependent and independent variables. Okay? Your input is always your independent variable. Your output is always your dependent variable. So if you want to make that note, you can. So these are dependent. I'm going to abbreviate that because I don't have room. And this is independent. Your input is independent of the other. Okay, I'm flipping page. Go to 154. The value of y depends on the value of x. Thus, y is the dependent variable, x is the independent variable. Okay? Those are the only two differences between the two. Now, the word relation is just literally talking about the relationship between two things. So when we write coordinate pairs, it's x comma y. It's the relationship of the input to the output. So in a relation, there are two things. There are a domain, which we always know is the range, or the x's. And then there's a range, which we always have known as the y's. Everybody already knows these things. So I don't feel like I need to spend much time on these. Am I correct in that assumption? Okay. Function. So when we finally get into function, I want you to keep in mind. So here's their example. They say y equals 2x plus 3. If they say write this in function notation, you would just write it in function notation for the input. So f of x equals 2x plus 3. Okay? These are interchangeable in my eyes. All right, so we're on example 2 there. Okay? This is talking about oranges. Consider the oranges that cost 30 cents a piece that we just discussed. They talk about them in the first example. We can illustrate the number of oranges and the cost of oranges using figure 3.21. So they use the formula C equals 30n. Okay, so if I was going to write this in function notation, I would say this. Cost of n is 30 times n. Okay? So literally, the difference between the two is the change in writing that parentheses n. That's really the only difference. Okay? So they do this nice little illustration on their pictures here, and they show you basically a relationship, okay, a mapping. You've all seen mappings before. They haven't been on oranges, but you've seen mappings before. It says that 1 goes to 30, 2 goes to 60, 3 goes to 90, 4 goes to 120, and 5 goes to 150. And because nothing from this side goes to more than one cost, this relation is also a function. There is no repeat in the x value. Okay, and we already kind of knew that as well. So still a review. Any questions on any of those words before we move on? Okay, and get into the stuff that I actually think you always need help on. So most of the stuff we'll see will be in ordered pair form. So I just need to remind you the vertical line test will tell you if something is a function or not a function. So looking at these 3 examples, is A function? No, because it crosses, and they show you the line right there. It crosses in more than one spot. How about B? Yes. What about C? No. Okay. A on this one? Yes. B? Okay, good. Didn't figure we'd have a whole lot there. On example 3, though, they talk about a little bit more, and I want to talk about it because we haven't been through examining the domain and range of those functions. So on example A, that's a linear kind of line, or kind of graph. Obviously, it's a line. Linear line doesn't make sense. So I want to talk about what my x's are. Notice that there are arrows going up and down. What are my x's allowed to be? Are my x's ever going to not be something? It'll be all real numbers, right? And it'll happen the same way as it goes up, because it'll always just continue to get bigger and bigger and bigger on the x's forever and ever and ever, amen, right? Same thing on the negative side of things. So if I wrote this in interval notation, it would be what? Well, all real numbers translates to what in interval notation? Negative infinity to positive infinity, right? In both parentheses on that side. Now when we look at the range of this one, is my range going to continually forever get big? My y values? What about as I go down? Yes, so again, that's going to be all real numbers, negative infinity to positive infinity. Now, this is where it gets different, so this is the one I really want you to pay attention to. My x values here, okay, as I go farther to the right, do they continue to get bigger? So it's going to travel toward positive infinity, right? What about as I went left? Does it ever... It starts at negative 3, right? So when I write this in interval notation, I will put, is it inclusive or exclusive of the 3? It's inclusive, so I'm going to put a bracket, and I'm going to put negative 3, comma, what? Infinity, right? And they give you that answer just below there. Now let's talk about our range, our y's. As I go farther down my y-axis, is this line going to continue forever to get bigger? It is. What about, or sorry, smaller? What about on the positive side of things? Is it going to continue forever to get bigger? It is. So what is the range of that function? All real numbers, negative infinity to positive infinity, right? So specifically, I wanted to show you and make sure that you understood and how to write that. On part B, we discussed that the domain was going to be in interval notation, a bracket, not a parenthesis, a bracket, negative 3 to positive infinity, okay? And the range there was the negative infinity to positive infinity. Okay, that was example 3b. Okay, example 4 starts asking us some interesting questions because of the way that one is graphed. So look at example 4 on page 157. It is a very wavy line. So you should be able to answer a few questions right off the bat. If it continues this pattern, okay, are there arrows on this? No. So what do we know about the graph that we're looking at? It stops, right? So looking at my x values, where do my x values peak? Remember, we're going along our x. 8, right? Where do they start? 0. So my domain then will be exactly what you just said. Is it inclusive or exclusive? Inclusive, right? So it's going to be a bracket. So I start at 0 and I go all the way to 8. Is that going to be inclusive or exclusive? It looks inclusive to me. Okay, next I want to talk about the range then. Sure. Okay, next I want to talk about the range. These are my y values. What is the highest y value? 3. What is my lowest y value? 2. Are they inclusive or exclusive? Inclusive, so we have brackets, right? So I go from my smallest one, which was negative 2, to my biggest one, which was positive 3, and I write it down. It really is all that you have to do. Any questions there? Okay. Awesome. I'm going to back up, and I'm going to ask you, is this relation a function? Yes. Passes the vertical line test, right? There is no repeat x. All right. Good deal. Example 5. Let's ask the quick question, is that a function? This right here is a slight slope, right? And it's kind of hard to see without, but if you look in your book, you can see that it changes slightly. So this isn't going just straight down. It's kind of going this way. And then remains steady, and then it kind of goes back up. But it takes a little while to get there, right? So yes, it is a function, okay, because it does pass the vertical line test. These are not straight lines. Had they been straight lines, it would not pass the vertical line test. So it would not be in a function, okay? Is there anything here? Let's just explain what's happening. Okay, so let's first read the chart. This is walking, running, right? Very obvious. Our x is in time, our y is in speed. So this is time to speed, right? Our input is time, our output is speed. So what is happening here at the 2? We started walking at a rate of 2. For how long? 5. And then what happened from 5 to like 5.1? We picked up our speed to 4, and then what happened? We stayed there for another 10 minutes, right? Because from 5 to 15. And then what happened? We stopped activity. This is 0, right? Our speed went to 0. We pretty much stopped activity, slowed down, jumped off the treadmill, whatever. Okay, and then took a what break? 5-minute break. And then what happened at 20? Went back up to about 5 miles an hour, and then stayed at that rate until 30. So we had how long at that high speed? 10 minutes, right? It's pretty much just being able to know what this chart is representing. Any questions? Cool. All right, number 4, the part that I feel like most of you struggled with was function notation. So let's look at this chart real quick, and we'll just go over these as fast as I can say them. Okay, so the first one, is that a function? Yes. Is it a relation? Yes, obviously. If it is a relation, or if it is a function, it's a relation, okay? So those are pretty synonymous. So that is a function. What about this one? What about this one? What about this one? Yeah, it does. These two never touch in the same spot. This one goes straight up, that one goes straight up. Okay? What about this one? Yes, these are all functions. Okay? These may meet at a v, but it's not more than one x value. Okay? So you need to know what these look like. This chart can be very helpful to you. You need to know what these kind of graphs look like so that you can know where they're coming from. Things that are just regular x, okay, they don't have anything special about them. They're just regular x's. They have a power of 1 or a magnitude of 1. They are linear in shape. Okay, we've already done a chart like this in Algebra 2. Here we have x squared, which makes a parabolic shape. Okay, and then we see something as 1 over x. So this is really, okay, if you want to make this note, x to the negative 1. Okay, x to the negative 1. The reason that this has a point where it doesn't, this is a point, or actually more of an equation of discontinuity is what it is. So this point of discontinuity here is because y, or x, cannot be equal to 0, because that would make this undefined. Okay? If x was equal to 0, it would be 1 over 0, and that would make an undefined fraction. So that's why there's nothing that can ever touch where x is equal to 0. Okay, because that would make it undefined. Next, the absolute value, we always get that V shape. And if you ever forget, think abs, think the V. Okay? Alright, any questions over this chart? You might want to put it on a note card, some of them anyways. Okay? And then you'll get into cubes, and y'all have seen those a little bit too, but anyhow. Alright, function notation. As we get into this, I've already explained it a little bit, so I'm not going to go into it too much. F of x, and then it shows you that x is your input, and there's your example. Okay, if it says find f of 1, you just plug in 1 for x, and then solve. And you'll write function notation will always, 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 I shouldn't say always, 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 pretty much always be an ordered pair answer. Okay, function notation, we expect your answers to be an ordered pair. Okay, so if I say, this is, I don't know what example this is, say example 6. Okay, so if I take example 6 and it says f of x, and you can use your calculator for these kind of things, 4x, negative 4x squared plus 3x minus 2. If you plug that into your calculator and it said find first a, which is f of 2, I would simply plug in 2 for everywhere I see x. So it's negative 4 multiplied by 2 squared plus 3 times 2 minus 2. Okay. Now if I put this in my calculator under the y equals function, I would just press trace 2. Okay, it makes my life just super easy. On B, you would do the same thing. Okay, but when you write your answer, it looks like this: f of negative 1, and you plug it in: negative 4, open parentheses, negative 1 squared plus 3 times negative 1, negative 2. Then you solve. I trust in your abilities to solve. And is everybody good with me not working these all the way out? Okay. Okay, cool. Is there any questions that specifically that y'all have seen on 3.2 that you would like me to kind of address before we stop? Speak now, forever hold your peace. 3, 2, 1. Awesome.